Hey there, Joe. This is Mr. Conklin. I'm in the behind the iPad here. I'm just about to come into the front. We're actually at our regular classroom. I was kind of hoping to record this at home with where all you'd see is my hand writing on this pad, but didn't quite happen. So let me see what we can do here. 56CC has been filling up my board with a bunch of scribbles. So let's see what we can do. I've got a list of the problems that your mom sent, and this is all on part 2. Let's start. Is 11 through 14, which are graphing problems. Then we have 22 through 25, which I think are the arithmetic, find the missing terms in the arithmetic sequence. And then the 2 extra credit clusters. I'm just going to call them extra credit 1 and extra credit 2. So they're 2 different pages. So let's see what happens. I'm going to start with number 11. This is, so ... 37 blank, and then let me enlarge this so I can actually see what I'm doing. And I'm right here, so I'm not going anywhere. So 37 blank 23 ... And they said that these are all arithmetic, which means that you add the same number repeatedly in order to get the next term. Now, you notice there are 2 jumps here. This is going to be plus D, because D is the common difference for these things. So if you take the entire jump, it's plus 2D. And how much is that? Well, from 37 to 23, you notice it's going down. 37 to 23 is going to be negative 14, I think. So you're adding negative 14. So in other words, 2 jumps carries you down 14. So you'd say 2D equals negative 14. And with a little algebra, divide by 2 on both sides. You can get D equals negative 7. So we now know what the counting thing is, and we can use it. Each time you go forward, you're going to go down by 7. So the missing term is 37 minus 7, or 30. Does that make sense? Let's try number 12. It's the same sort of trick. Again, it's arithmetic, and it's 23 blank blank 5, blah, blah, blah. 23 blank blank 5, and then blah, blah, blah. Now, if you notice, there are 3 jumps, so I'm going to call this 3D. And this particular overall jump, you do, by the way, a quick way to do it is 37 minus 23 to get this. And you do 23 minus 5, so it's 18, but you notice it's going down, so I'm going to write this as negative 18. Does that make sense? I see, how far did it drop? It was 18. And how many jumps is that? 3. So if 3 jumps drops you negative 18, drops you 18, let me just write that here. Then how much is 1 jump? I'll divide both sides by 3, and D equals negative 6, which means that for every single jump, you're going to go down 6. So it's going to be down 6, down 6, down 6. I hope you're not superstitious. That's not the Antichrist number, it's a math problem. And 23 minus 6 is 17. 17 minus 6 is 11, and 11 minus 6 is 5. So the 2 missing numbers are 17 and 11. Let's try the third one. Number 13. This time we have 3 missing numbers. So it's blah, 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 negative 16, and then blank, 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 followed by 8. Now notice it's going from negative to positive. That means it's going up. Think of it like temperature. This is 16 below 0. This is 8 above 0. It warmed up. So how much did it go up by? Well, 16 below plus an extra 8 above is going to make 24. So it went up by 24. And how many individual jumps? That's going to be 4. There are 4 jumps to get from here to here. So 4 jumps, so 4 of these D's is equal to 24. divide by 4 on both sides, and you get d equals 6. And that's what we're going up by. Now careful, this is negative. So negative 16 plus 6 is going to get less negative. It's going to be negative 10. In other words, these two fight, if you like. So a negative and a positive, when they add, they fight, and whoever is strongest wins. So negative 16 plus 6, the negative 16 wins by how much? By negative 10. And then add another 6 to that, and it'll raise to negative 4. Then raise to 6, and it'll go up to 2. Make sense? And last but not least, number 14 looks like blah, 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 negative 32, and then another 3 blanks, followed by negative 4. Blah, blah, blah. Now again, what happened to go from one to the other? This is going up, it's increasing. From negative 32 to negative 4, do a little subtraction in your head, that's 28, and it's going up. It's going up by 28. How many jumps? 1, 2, 3, 4. So if there are 4 jumps that are carrying you up 28, divide both sides by 4, and d equals 7. So that's what each individual jump is going up by. So plus 7, plus 7, plus 7, and this should match plus 7. So negative 32 plus 7 gets less negative. It's negative 25. Negative 25 plus 7 is negative 18. Negative 18 plus 7 is negative 11. Negative 11 plus 7 is negative 4, which works. So those are your 3 missing numbers. And that should handle these 3. Okay. Again, if you need to go over this, the nice thing about a video is that you can just rewind it and play it again as many times as you like. So go ahead and do that if you get stuck in any of those. So let me clear the screen, the board. Such a tech geek. Clear the board, and let's try number 22 through 25, which are graphing problems. There are 2 ways to do the graphing problems. There's a long way using a table, and there's a short way using what's called slope and y-intercept. If you have a special form called slope-intercept form, you can do that. So 22 through 25. There were a couple of graphing, okay, the 20 and 21 seem to be no problem. So number 22, refresher course. Anything that's of the form y equals mx plus b, where m is a number and b is a number, is called slope-intercept form. The reason they call it that is because the first, and this is in order, the first number is the slope of the line, and the second number, the b, is the y-intercept, where the line crosses the y-axis. So if you have like a line in the middle of nowhere, this is the y-intercept, which is the starting point. Okay? So, and if you remember, slope is what we call rise over run. So rise is the up-down part, and run is the left-right part. So if I were to, well, let's just take this one, number 22. Y equals 7 over 5x plus 4, I think. Let me double check that. Yeah. Well, 7 over 5 is the slope. It's the rise over the run. So the rise is 7 and the run is 5. So it's always a fraction. If it's not a fraction, you can make it a fraction by putting it over 1. But this one was a fraction already. And this is the y-intercept, which, by the way, is our starting point. So you start here. If a y-intercept is positive 4, that means you go up 4 spaces. And there's your first dot. So you're going to need 2 dots in order to make this problem work. So this is 4. Let me label that. And then it's rise 7, and that's positive 7, so you go up. And then 5 spaces to the right. And there's your point. Now there's another way to do that. On the graph that I gave you, there's not a lot of room there. I think it only went up to 6. The graph stopped here. So what do you do if the graph stops there? You could put some extra dashes there. I'm okay with that. Or instead of going up 7 over 5, you can go down 7 and left 5. And you should get the exact same line. Actually, look, both of these points connect on the same line. Which either one of these 2 points is totally fine. As long as I grab the correct line, you're good to go. I think this is what the worksheet was expecting you to do. But you can go off screen if you just make a bunch of extra dashes for your own, and then go over 5. So this would actually be up 5, 6, 7, 8, 9, 10, 11. It'd be up to 11 and over, like over 5 and up 11. This thing would be over negative 5, comma, negative 3. Does that make sense? So either point would be totally fine. If you wanted to do this by hand, I would say that the slope-intercept form is much easier. I'll show you the table method of doing this in a minute, but it takes about 3 times as long. So I would not recommend doing that. 23. Let's try the same trick. Again, this going up or going down, you could do either or, whichever is easiest. It's just if you ran out of room, just make some extra dashes or go the other way. Y equals negative 2/3 x plus 3. Now, if the negative is right in front of a fraction, here's what I do. Add the opposite. Put it on top. That pretty much is a foolproof way of making sure you don't get it wrong. Let me show you how fast this could go. Remember, this is the slope, rise over run, and this is the y-intercept, which is where you're going to start. Now again, the y-intercept, remember, is the y is up, down. The x-axis is left, right. So don't go to the right 3, you go up 3. Okay, and I'll label that. And then slope of negative 2 over 3, how do you do slope of negative 2? A rise of negative 2 means you're going down to a fall, if you will. And then 3 to the right, because the 3 is still positive. Some people make the mistake of, if they see this, they're wondering if this, well, does that mean everything's negative? So they do that. And the answer is no, because negative divided by negative would make a positive, which would be bad. And we want the answer to be negative. So you can have a negative on the top or a negative on the bottom, but not both. I prefer having it on top because you don't mess up your denominator. Whenever you want to find a common denominator, the last thing you want is to have a negative down there. So anyway, you go down 2, and then run 3 to the right. And then, I should mark the 3 over here. Here's your line. So again, y-intercept, boom. And then slope, boom, boom. Connect and done. Okay? 24 looks like this. Y equals negative 5 halves x plus 5. Here's another one. They have the negative out in front. Don't make both of them negative. That would not be correct. Add the opposite. And put it on top. Don't mess up the denominator because you never know when you'll need a common denominator. So, let's see how fast this goes. The y-intercept is positive 5. Put it down. Then rise negative 5, which is all the way down, and then run 2 to the right, and you're done after you have the line. Does that make sense? So let me clear some space here and do number 25. The light bulb is all out in that part of the room, so trying to stay more on the left-hand side of things. Number 25, y equals negative x plus 1. This is a little tricky for several reasons. First of all, a negative, what do we do with it? Well, there's a number hiding in front of the x, a 1. It's really negative 1. But I needed a fraction. Put it over regular 1. You've just fixed slope, your slope-intercept form. Now, let's try it. The y-intercept is 1, so let's do that. And then the slope is rise -1, which is go down 1, and go 1 to the right. You have just drawn your line. Okay, so hopefully that should do 22, 23, 24, 25. And if you have any other questions, shoot me a quick email and we'll see what happens. And if you ever want to see these again, just rewind the video and go back. Now, you had some questions about the extra credits on part 1 and on part 2. Let's see if I can find part 1. It's on a different screen. I'm still here. Blah, 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 blah. Determine the number of terms in each arithmetic series. I want to make absolutely sure I'm looking at the correct number for you. Blah, 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 blah. Oh, it's the 4th picture. Hang on. So I see number 26 and 27. And I see number, oh, interesting. Hang on a second. Is that 36? Yeah, 36, 37, 38. So determine the number of terms. A equals -8. Is this the copy that I have? Sorry, this is really boring to look at. Yes. So let's do number 36. This is 36, 37, 38. This is on part 1. So determine the number of terms in each arithmetic series. There's only one. So A1 is -8. This is number 36. So A1 is -8. That's the first term. A sub n is -56. And S sub n is -416. Now the formula that makes this work, and this is one of the formulas you'll have to memorize, when you're doing arithmetic and geometric, you have a formula for A sub n, a formula for S sub n, and sometimes a formula for S infinity. A sub n, it's A sub n is equal to A1 plus D parentheses n minus 1. I'm going to scoot this over a little bit so I have some room. I don't have to crowd. This one for geometric, is equal A sub n is equal to A1 parentheses R to the n minus 1 power. And I think, oops, this is just the category. So S sub n, that's capital S, is equal to n over 2 parentheses A1 plus A sub n. This is also called Karl Gauss's formula. For geometric, S sub n is equal to A1 parentheses, big parentheses, 1 minus R to the n over 1 minus R. And then S infinity, there is no formula for arithmetic, and there is a formula for geometric. It's A1 parentheses 1 over 1 minus R, which is a lot easier than the top one, but only if 2 conditions apply. If it's geometric, and if R is between -1 and 1, not counting -1 and not counting 1. So, which formula are we looking at here? They want to know how many terms. They did say that this was arithmetic. So take a look. Does any formula in this list of arithmetics formulas use A1, A sub n, and S sub n? Yeah, this one. So I'm going to use this one and just plug in everything I can find. S sub n, they actually give us a value for that, -416, equals n over 2. They did not tell us what n is, so just keep it. And parentheses, A1 is -8, plus A sub n is -56. At this point, your job is to get n by itself, to solve for n. So I can simplify these. -56 plus 8 is -64. So it looks like this. -416 equals n over 2 times -64. And then these cancel down if you want to put a 1 underneath here. 64 and 2 reduced to 32, it's negative, because and 1. So we're looking at negative 32 times n is equal to negative 416. And does that work? By the way, negative 32 divided by 1 is negative 32. To get n by itself, divide both sides by negative 32. You can do this off to the side, or on this particular test with these, you could use a calculator. It actually does work. And you get 13. And that's exactly what they want. It says determine the number of terms. N always stands for the number of terms. And they said determine the number of terms n. So n is equal to 13 and you're done. So there are 13 terms in this arithmetic sequence. Okay. Let's try geometric, the number 37. We've got a sub 1, 37. A sub 1 is equal to 2. R is equal to 4. And S sub n is equal to 42. Now there are multiple ways to do this. A couple of people just sort of did this by hand. This is geometric. I'll show you how a few other people did it. Here's the official way. Which formula in the geometric stack uses S sub n, which is kind of a hint, R, and A sub 1? This one. This one, it uses S sub n, A1, and R. So let's try it. S sub n, they actually give us an answer. It's 42 equals, I'm using this formula right here. And then A sub 1, which is 2, then parentheses, 1 minus 4 to the n over 1 minus 4, because I don't know what n is. So we can't do a heck of a lot just yet, but all I did was just plug in stuff here. Now, let's see what we can do with this. I cannot simplify the top yet, because I don't know what n is. I can simplify the bottom. This is negative 3. So it looks like this. 42 equals 2 times 1 minus 4 to the n over negative 3. Now I want to get n by itself. Algebra says get rid of what's farthest away from the variable first. I want to get rid of the 2. Divide by 2, because they multiply by 2. And you should get 21 equals this fraction. 1 minus 4 to the n over negative 3. Still with me? Still trying to get n by itself. What's farthest away? The negative 3. They divided by negative 3, so I'm going to multiply both sides by negative 3 to cancel it. I now have 1 minus 4 to the n is equal to 21 times negative 3 is negative 63. Still trying to get n by itself. Still trying to cancel what's farthest away. Be careful here. A lot of people assume that you add 1 to both sides to cancel this. Add the opposite. The negative belongs to the 4. It does not belong to the 1. You subtract 1 on both sides. Cancel. Negative 4 to the power of n is equal to negative 64. So which one is farther away? The negative or the 4? The negative. Divide both sides by negative 1. I've got equal signs, right? And you will get, negatives cancel, 4 to the n, I flipped it around for easy figuring, is equal to 64. Now this you can kind of do by trial and error. 4 to the first power is 4. 4 to the second power is 4 times 4 is 16. 4 to the third power is 16 times 4, which is 64, and guess what we just found? N is equal to 3. And you're done. That was a little more involved than number 36. It's not, we don't have a really ready way to get rid of that 4 here. That's actually a pre-calc problem, believe it or not. That's something called a logarithm. But if you just do it by hand, that's fine. Does that kind of make sense? So in other words, plug in everything you have, and then just start whittling away things until you get n by itself, or as close as you can. And then if you get stuck with something like this, and they say, I can't get rid of the 4, I don't know how, just start guessing and checking. Usually it's small enough that only a few guesses will get you to where you need to go. Okay? Let me look. Evaluate the following series. This is sigma, from n equals, let me make this larger so I can actually see what I'm doing. Okay, sorry. There you go. So n goes from 0 to 19 as a sigma of n. There are at least two ways to do this, number 38. What this means, sigma means sum. And it means, here's the formula you use. You plug n in here and see what you get. It's going to be 0 plus 1 plus 2 plus blah, 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 all the way up to 19. You could do that by hand because it's not that long. So if you take 5 minutes, you could probably get it. But if you notice, how many steps are used to get up to 19? Now, this is a little tricky because we're starting from 0. How many jumps does it take to go from 0 to 19? Well, to get from 0 to 1 is 1. To get from 0 to 2 is 2. To get from 0 to 3 is 3. To go from 0 to 19 is 19. Think that makes sense? To go from 0 to anything, you're going to have the same number of jumps as the number itself. Like, to go from 0 to 2, 2 jumps. So to go from 9 to 19, it's got to be 19 jumps. So we'd say that, well, I'll show you how to do this in a second. This is an arithmetic sequence. 0, 1, 2, 3, 4. If you prove it, d is equal to 1. And we also know that a1 is equal to 0. We also know that the last term, a19, is equal to 19. So we now know that, how many terms are there? Well, I would have said 19, but you got to count 0. N is 20. That kind of makes sense? N is always the number of terms. And if you have a 0 there, like 1, 2, 3, 4, 5, 6, 7 up to 19 is 19 numbers. Now there's 20. There's 19 jumps between them, but they're 20 numbers. So you might remember this formula, n over 2 parentheses a1 plus a sub n. So if n is equal to 20, oh, that's only when you're doing the, oh, well, whatever. Okay, I'll show you in a second. Should be 20 over 2 times a1 is 0. And a sub n, you might say, well, what is the 20th term? This is actually the 20th term. This is technically the first term, it's 0. So I should have said a20. So 0 plus 19, this reduces to 10. And 10 times this is 190. And that should give you your answer. That's one way to do it. Frankly, on this one, since it's so small, you might just want to add it up by hand. That's totally fine. Just, I'd like people to recognize this is arithmetic, and you can use the formula to get it. Okay, it gets a little tricky finding out, well, what is n? When you start counting from 0, it throws everybody off. Let me see the other extra credit that you were asking about. Part 2, let me scroll real fast. Yes. For extra credit number 2 is 26, 27. Is there anything else on that page? There is a 28, yep. So 26, 27, 28, and that should finish this up of all the questions that I saw that were sent to me. So k goes from 3 to 12 of sigma. And we have a different formula. It's 2k plus 7. Okay? So what you do for these numbers is plug in 3. So it's 2 times 3 plus 7 is the first number. Then add that to the next one, 2 times 4 plus 7 plus blah, blah, blah. And then the very last number you'd plug in is 12. It's 2 times 12 plus 7. Let's calculate this. 2 times 3 is 6, plus 7 is 13. 8, this is 15. The next one would be 17, and then blah, blah, blah. up to, this is 24, 20, 31. This, you notice, is an arithmetic. And again, you could list these all out. So how many terms are there? Starting on 3, term number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 10 terms in here. You can just count those in fingers if you need to. Starting with number 3, term 3, 4, 5, 6, and 7, that's 5 terms. Term 8, 9, 10, 11, and 12, got it. So there are 10 terms, which means that n is equal to 10. You can use this formula now. S sub 10 is equal to 10 over 2. First term, which we have, and the last term, which we now have, because we extended it out. So this is 44. This is 5. This should be 220. Is the answer to that one. And it is. Good. Extra credit number 27. Evaluate the geometric sequence described. We've got sigma of m going from 1 to 10. This is number 27. The formula 2 to the power of m minus 1. Now, here's what you would get. Plug in a 1, 2 to the 1 minus 1, that's 2 to the 0. Then add that to the next one, which would be, it keeps going 1, 2, 3, 4, 5. That's what sigmas do, they count by ones. Then the next one is 2 to the 2 minus 1, which is 1. Plus, and then it'll be 2 to the second, plus 2 to the third, plus blah, 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 plus. The last one you plug in is 10, which gives you 2 to the 9th power. Now, if you actually simplify these, anything to the 0th power is 1, unless you have 0 to the 0, which doesn't make any sense. So 1 plus 2 plus 4 plus 8 plus blah, 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 plus, and if you look up or punch in 2 to the 9th power, this is 512. Okay. So how many terms do we have here? Well, this sigma says that there are 10 terms. And S sub n for geometric is A1 parentheses 1 minus r to the n over 1 minus r. Now, is this geometric? Yeah. And if you notice, they're multiplying by the same number over and over and over. R is equal to 2. That's what they're multiplying by. So you can plug this in. So S10 is equal to the first term, which is 1, in parentheses 1 minus 2 to the n, and we know what n is. 1 minus 2 to the 10th over 1 minus 2. Because n is 10, we plug it in for that. 2 to the 10th is 1024, I looked that up earlier. And 1 minus 2 is negative 1 on the bottom. Here's what it looks like so far. S of 10 is equal to 1, which doesn't do anything, over 1 minus 1024 over negative 1. What's 1 minus 1024? It's negative 1023. And what's a negative divided by a negative? Positive. Divide by 1 doesn't do anything. Oops. Multiply by 1 doesn't do anything. The answer is 1023. Okay. Number 28, make your own infinite geometric sequence which converges and which has an answer of 50. Now, geometric, they're basically looking for an S infinity, an infinite geometric sequence. Converges means that you can go forever, but it actually has an answer. It has a non-infinity answer. That's number 28. So basically we want an S infinity equal to 50. And you get to make up your own. Now, you have to give me the list of numbers that would actually do that. The funny thing is, here's the formula. S infinity is equal to A1, parentheses 1 over 1 minus R. But only if it's geometric, which means you're multiplying by the same number over and over. And R is between negative 1 and 1. So it's a small fraction, like 1/2 or 1/3 or something like that. Now the thing is, if you're making your own, You can pick one of these. Don't pick both, it might not work. But if you pick one of them, you can find the other. If you pick this one, you can find the other. Just for fun, I want to pick an r, just because that's usually the trickier one to do. I'm deliberately going to choose r equals 1/2. How come? Because it's in the range, and because it's easy. You could do like 3/29 if you want, but ew, why would you? So here, s infinity, they want the answer to be 50. Does that make sense? So you just plug in s, that's 50. And then I have no idea what the starting term is, but I do know I'm using 1/2. Let's just see where it goes. 1 minus 1/2 is 1/2. 1 divided by 1/2. How do you divide by a fraction? You multiply by the reciprocal. The reciprocal of 1/2, it's 2/1. And so 1 times 2/1 is just 2. So it's 2a1 is equal to 50. And this is actually a pretty easy problem to do now. Divide both sides by 2. a1 is equal to 25. So here's what you should do. a1 is equal to 25, and r is equal to 1/2. So what does the sequence look like? Start on your first term. Plus, and now what this means is you're going to multiply the number by half over and over and over and over. So 25/2, 25/4, 25/8, plus, and on forever. And I guarantee you, this will add up to 50. And that is that. So again, if you have any last minute questions, let me know. But if you don't, then God bless your efforts. Have your mom send me this is still my hand, I'm still here. Have your mom send me an email when you're ready to take that test, and I'll shoot it to you. I have it at home, so I can send that anytime you want. So this is Mr. Cochran's hand saying goodbye. Hope that helped, and we'll talk to you again. So, oh crumbs. A whole bunch of these things that I wasn't on screen. I hope that didn't mess it up too badly. If there are any of those that you missed, let me know. Oh, that was embarrassing. So hopefully I'll just have a good long shot of that. So, okay, good enough. So we'll talk to you later. Take care. God bless. Bye-bye.